Model Mania 2021. This was the year that we did 3D Experience World virtually and therefore did a virtual Model Mania. So one of the things we did to simplify things was to not do a phase two. So that all we did was we asked you to model the part and run a simulation. So with that being said, let's go ahead and walk through how we might approach doing this. First thing I see when I look at this drawing is I see that central boss, 60 millimeter and 50 millimeter radii. Then I'm looking at that bottom base that has the 4 holes in it. I have the hole locations, the big 75 millimeter radius that goes across there, so I'll probably attack that next. The next thing I do is I see this shelled out area at the bottom, a 5 millimeter wall thickness there, and I'm going to do that early as opposed to later because I don't want to mess with the wall thicknesses of some of the other features that are above that. Next, I see this clamping boss that goes on there. So that looks pretty straightforward. I'm going to add these fillets. I'm going to add them a little bit early here. And I think you'll see as we go through. It just makes things a little bit easier for me. Next, we're going to add this 3 millimeter saw cut, and I'm going to do that before I add the counterboard hole and the tapped hole. So there's 2 holes that actually go through that clamping boss. One of them to allow that to clamp onto a shaft or whatever that's mounted to. Next, we're going to add our material, plain carbon steel, and then finally we'll run our simulation, apply the load, and then we'll fix a couple of those blue faces there. So let's go ahead and get started. I'm going to do this, and I'm going to start on the top plane here. Let's go ahead and start on the top plane, and I'm going to start by creating a lot of the geometry kind of in one sketch. 50 millimeter and 60 millimeter are the 2 diameters that I want to use to define those. Next, what I'm going to do is I'm going to start to lay out the holes for that base plate, and I'm going to do that just by drawing in a center line there. The hole diameter is 14. The radius is 12 times 2, which is 24. That gives me that little radius of the lobe on the outside of that base plate. The 2 dimensions there are 40 and 40, and I want to pattern this around the entire geometry. But before I do that, I'm going to add that 75 millimeter arc in there. I'm going to make these 2 items tangent to each other. On the other side, I really don't know where it's going to go, but let's go ahead and pattern these at this stage. We're going to make that pattern at 4 of them. You can see that all the information in the property manager looks about right. And then we just drag that onto the circle to build a coincident relationship and also add a tangent relationship. That radius is 75 millimeters, so we'll add that. And then finally, we'll just extrude it. So I'm going to grab all these contours and we'll extrude all these in one go. That's going to be 20 millimeters of depth there. So that's my first feature. Next, we'll shell it. So here I'm going to shell this early as opposed to later in the process, and that gives me my 5 millimeter shell thickness. Using that same sketch, I'm going to extrude that one up to define that cylindrical boss that sticks up, and that's going to be 60 millimeters tall. Next, we'll go ahead and define that clamping lobe that goes on the side there. So just draw a line, transition to an arc, transition back to a line, and then close up my sketch. We're going to make this 12 millimeters as the radius. We'll define the angle to be 30 millimeters. And then I'm going to draw a center line to define the symmetry. So I'm going to draw that in from the center of the arc to the midpoint of the line and then make that horizontal. And that will establish my symmetry. The location for the center of that lobe is 36 from the origin in the horizontal direction, and the vertical direction it's going to be 42. Now we have one under constrained piece of geometry here, that line. So I'm just going to constrain it by just dragging it onto the silhouette edge defined as I view that in wireframe. So now my sketch is fully constrained. Using Instant 3D, I can just grab that arrow and drag that out. I'm going to hold down the M key here, and we're going to drag that to make that 36 millimeters wide. Now, one of the things you might notice here is I have a little extra face in there. When I see these extra faces, whether it's adding or removing material, one of the things I think of is I want to delete that face. Using the selection helper here, I can choose all the coplanar faces that are coplanar to the one I selected, and it'll remove those. And that'll help me with the filleting. Speaking of filleting, all I need to do is choose that one face, couple of edges here. On the bottom side, we'll choose that face. That gets a lot of them. But this vertical face, using the selection helper, I can get all 8 of those similar vertical edges associated with that. not necessary. One of the things I like to do here is actually add some color to it, and that allows me to visualize that, yeah, I got all my fillets applied here. Now that I have all those fillets on, I'm going to go ahead and put my saw cut in. I want to get my saw cut in before I put in my counterbore hole, and I think you'll see why, because the counterbore hole goes up to that saw cut. I'm just going to do this by simply drawing a single line using the cut feature here. We're going to say through all. I don't need a direction 2. I want it to be a thin feature, mid-plane, 3 millimeters. And there's my saw cut. Next, we'll put on the hole wizard holes, and those are going to be 8 millimeter counterbore holes. We'll go ahead and define those as socket head cap screw, 8 millimeter normal up to next. And one of the things I like to do when I'm positioning these holes is to turn on my temporary axes to locate that, as opposed to locating that to an edge of a fillet, which may get deleted down the road or removed. So I like to use the temporary axis. That defines the counterbore hole. Next, we'll add another hole, and this is going to be the tapped hole, M8. We'll position that one again along that same axis there. Go ahead and position it on an inside face, and that creates that. We'll turn off our temporary axes, and there our geometry looks good. The last thing we need to do is we need to define the material, in this case plain carbon steel. So the next thing we asked you to do was to run a simulation. You could use Simulation Express or SolidWorks Simulation. My preference is SolidWorks Simulation. We're going to define the fixed faces, or the fixed geometry, in this case the 4 cylindrical faces here. We'll go ahead and define those, and then we're going to add a load. We'll apply a force to the central cylindrical face there. That's going to be 10,000 newtons, and we'll define our direction there by choosing that edge, and this is going to be 10,000 newtons. Make sure our direction is going correctly, and there we've defined that. The last thing we need to do is to run our simulation. In no time at all, we get our simulation results. We can hide our symbols, and I'm just going to animate this so I understand that, yeah, this is how I would expect it to behave. And then finally, we're going to ask for the factor of safety. I'm going to max out our factor of safety at 10 here just for visual purposes, and you can see I get a factor of safety of around 3.3. So that's Model Mania 2021.